Hello students, in today's class we are going to discuss about heating effect of electric current. Heating effect of electric current means whenever the heat is produced due to the electricity, then that is called as a heating effect of electric current. Now we all know about law of conservation of energy. According to the law of conservation of energy, energy neither created nor destroyed, but it can transform from one form to another form. So all the energy, it can be any energy, like kinetic energy can be converted into potential energy can be converted into kinetic energy, or all means another form of energy like nuclear energy can be converted into electric energy. So whenever we are discussing about energy, so energy can be transformed into one form to another form, but energy never created or destroyed. That is why law of conservation of energy. Energy neither created nor destroyed, it only transformed from one form to another form. So if we consider the electric energy can be converted into kinetic energy, for example in electric motor. So in electric motor, whenever we give the electric energy, that electric energy is converted into kinetic energy. Next, electric energy can be converted into magnetic energy as in case of electromagnet. Electric energy can be converted into heat energy as in case of heaters, oven. Electric energy can be transformed into light energy as in case of bulb tube light. Electric energy can be converted into chemical energy, for example in case of electrolysis. So what is heating effect of electric current? Conversion. Okay, it is a conversion of electric energy into heat energy in purely resistive circuit. This is very important. In purely resistive circuit, the circuit should contain resistance. It should be a resistive circuit. Is known as heating effect of electric current. So if we draw the simple circuit, resistive circuit, that's why in this circuit we used one resistance R, battery with potential difference V, and one switch. So as the switch is closed, the electric current is circulate in the circuit. So as the electric current starts circulating in the circuit, it produces what? It produces heat energy. It means conversion of electric energy from the source, from V, it is converted into heat energy. And such phenomenon is called heating effect of electric current. So we can write mathematically that heat energy which produced due to electric current is given by I square RT. This is the mathematical expression, I square RT, and in place of H we can write as a work also, means work done. So we can say electric work or it is a electric energy, because energy is your amount of work done. So one more expression is this, V square by R into T, or one more, H equal to VIT, where I is current, R is resistance, and T is your time in which the charge is flowing in the circuit. So how we can define this one, electric energy? So electric energy is the amount of work done when a charge Q flows through a conductor at some potential difference. Means by applying certain potential difference, if the charge is flowing around the means inside the circuit, in the circuit, then that is called as a electric energy or electric work. So once again I am repeating the definition. Listen carefully. Electric energy or electric work. It is the amount of work done when a charge Q flows through a conductor at some potential is called electric energy or electric work. So SI unit of electric energy or electric work is given by joule, and we all know that V is equal to what? V is equal to W by Q. So W is equal to, W means work done. Work done is equal to V into Q. So electric work is the product of potential difference and charge. Now, since the SI unit is your joule, we can define the 1 joule also. 1 joule means amount of work done when a charge of 1 coulomb flows through a conductor at a potential difference of 1 volt. That is why 1 joule, it means work done you make as a 1 joule. Q you can take as a 1 coulomb, and V you can take as a volt. So 1 joule is equal to 1 coulomb into 1 volt. Now in a simple way we can write electric energy is the product of power and time. That is why power into time, and power is given by the product of VI. So VI into T, which is equal to VIT. Now see the derivation of these 3 expressions. How we can derive these 3 expressions. I square RT, V square by R dot T, and VIT. So we know that V is equal to W by Q. So W is equal to V into Q. Now since I is equal to Q by T, electric current is the rate of flow of charge. So Q by T, it means Q we can write as I into T. Substitute here. Therefore, W is equal to V into I into T. So in simple way we can write VIT. See, we got this expression. W is equal to VIT, and in place of W we can also write as H. Next, by using Ohm's law, V is equal to RI. So in place of V, you put the RI. So W is equal to RI into I into T. So RI square T. So I square RT. So we got this expression also. I square RT. Now again we can use V is equal to RI. Now you change the expression of I. So I we can write as a V by R. Put here. Therefore W is equal to R into, in place of I square you write V square by R square into T. Cancel this and this. So W is equal to V square by R into T. So this is the third expression. So very easy derivation. You can practice this one so that you can also do the derivation easily. So first one will be your W is equal to VIT. Second one W is equal to I square RT. And the third one is your W is equal to V square by R into T. Now come to the electric power. Electric power, we all know that power is measured in watt. So SI unit of electric power is your watt. Now electric power is the work done per unit time. Which work done? Electric work. So electric work per unit time is called electric power. Or you can write in this way also. The rate of doing electric work done in 1 second is called electric power. So power is equal to work by time. Now let's find the three expression for the power. Just we have to put this P equal to W is your VIT. So VIT divided by T. T get cancelled. It is VI. So what is power? Power is the product of voltage and current, or product of potential difference and current. The next, put next one, I square RT. I square RT by T. Again T get cancelled. This one will be I square R. And the third expression, V square by R. V square by R into T by T. So T get cancelled. This is V square by R. So these are the three formulas for electric power. Power equal to VI. Power equal to I square R. Power is equal to V square by R. Now SI unit is your watt. Now see the some bigger unit of electric power. 1 kilowatt. Kilowatt is the bigger unit of electric power. So 1 kilowatt means 1000 watt. Then 1 megawatt. 1 megawatt means 10 to the power 6 watt. 1 horsepower. HP means horsepower. So 1 horsepower is equal to 746 watt. And in numerical, in place of 746, you can use 750 watt for easy calculation. Now, see the commercial unit of electric energy. So, commercial unit of electric energy is your watt hour. What is watt hour? Because electric energy is your power into time. So, unit of power is what? Unit of power is your watt and time unit is your hour. So, watt hour is the commercial unit of electric energy. But this is your smallest unit. Now, for the bigger unit, we can write kilowatt hour. So, 1 kilowatt hour equal to 1000 watt hour. Come to this point again. 1 watt hour is also equal to 3600 joule. 3600 joule. See how we get this one. See here. 1 watt hour. Okay, I'll use the different color. 1 watt hour is equal to, watt means what? Watt means your joule per second. So, joule per second. And 1 hour means 3600 second. So, 3600 second. So, second get cancelled. This is equal to 3600 joule. That is why 1 watt hour is called as a, means 1 watt hour is equal to 3600 joule. Now, biggest unit is kilowatt hour. So, 1 kilowatt hour is equal to 1000 watt hour. Now, in place of watt hour, you can write as a 3600 joule. So, 36 into 10 to the power 5. And if you use the decimal, it will be 3.6 into 10 to the power 6 joule. Now, this 3.6 into 10 to the power 6 joule is also called as a BOT. B-O-T. B-O-T means board of trade unit. So, 1 board of trade unit, 1 BOT is equal to 3.6 into 10 to the power 6 joule. Now, 10 to the power 6 means mega. So, you can write as a M. So, 3.6 mega joule. I hope all of you have understood this topic. That is your heating effect of electric current. So, your work is you have to make a short note on this topic which I explained today. Till here, commercial unit of electric energy in A4 size paper, and that one you have to make for your internal marks. So, do neatly. You can take the help of all this content which I wrote on the board, and also from your textbook also you can take the help to prepare the note on heating effect of electric current. Thank you and take care.